Hey gang, today we're going to talk about chapter 7.2, which is properties of rational exponents. We might quickly recall that rational numbers are numbers that can be written as fractions, so these are going to be fraction exponents. So the great news is that rational exponents follow all of the same properties of exponents that you've known now for years. So for us that was back in 6.1. So here's a list. I'm not going to go over them. I copied from your chapter 6.1 notes the list of exponent properties. You should know them. They all still apply if you have fraction exponents. So let's use our exponent rules here. So the first one, we have 6 to the 1/2 power times 6 to the 1/3 power. Remember, if we're multiplying with the same base, we add our exponents. So we're going to keep the base of 6, and I'm going to add 1/2 plus 1/3, and I'm just going to get a quick common denominator. So that was times 3, and that's times 2. So it looks like 5/6 is my exponent. So 6 to the 5/6 power. The next one here, we don't have the same base, but we have a product to a power. So recall that that power goes to everything in the product. Okay, and so we're going to have 27 to the 2/3 power times 6 to the 2/4, which is going to be 1/2. And that actually, I think, simplifies a little more, but that's not the point of what we're doing right now, so we will simplify that more a little later. Same thing with the next one as far as the power going into both. So if I multiply, I'm going to get 4 to the negative first times 2 to the negative first. And then remember, where do those negative exponents on the top go? They go down to the bottom, so it's 1 over 4 times 2, that's a times, which is going to be 1/8. And our last one here, if we are dividing, we subtract our exponents. So there's a 6 to the 1 on top, a 6 to the 3/4 on the bottom. So we'll keep our base, subtract our exponents. 1 minus 3/4 is 1/4. So exact same properties, you just are now doing it with fractions. So there's a couple of ways to tackle these. First of all, you could switch them over to have exponents. Remember, that's what we did in 7.1. So this could be 25 to the 1/3 times 5 to the 1/3. And then because they have the same exponent, you can pull the exponent out and have 25 times 5 to the 1/3, which is going to be 125 to the 1/3, which is the same thing as the cube root of 125, which is 5. There's one way you could do it. You could do the other one the exact same way. Or you can use, this one would be your product property of radicals. And the fact that they have the same index, we can go ahead and multiply them together and just make the cube root of 125, which is then 5. And the same thing with the other one, but this would be the quotient property of radicals. Yeah. My pen and I today aren't agreeing how to write. Okay. So because they have the same index, I can go ahead and divide them. It's the same thing as putting it all under 1. And you only want to do this if it actually does divide. So the cube root of 8 and the cube root of 8 is 2. So that's probably your quicker method of doing those, is your product property of radicals and your quotient property of radicals. So here's just a checklist to know when you have simplified something, because a lot of what we're going to do is simplify. So apply all of your properties of radicals. So the product property and the quotient property that we just talked about. Removing any perfect nth powers. I mean, and that goes back to even when we were doing just square roots. If you have the square root of 24, that can simplify. I can take out the square root of 4, and you're going to get your 2 square root of 6. So you're simplified when you've removed all of those perfect nth powers. And we also need to remember to rationalize any denominators. You can't keep those square roots in the denominators. So the removing the perfect nth powers, if we start here with the 4th root of 64, when you might go, well, what are my perfect 4th roots anyway? So your perfect 4th roots, 1 to the 4th power would still be 1. 2 to the 4th power is 16, and does 16 go into 64? It does, 4 times. So we can break this into the 4th root of 16 and the 4th root of 4, because that still makes 64. 4th root of 16 is 2, so we're going to get 2 4th root of 4. So that's now simplified. This next one here, I'm going to break up into the 4th root of 7 over the 4th root of 8. That's my quotient property. And then somehow I need the bottom so I can lose this radical. Well, instead of actually multiplying by the 4th root of 8, which is maybe what we might have looked into, actually I think I want to multiply by the 4th root of 2. And so then you might ask yourself, well, why the 4th root of 2? Because if I multiply these on the bottom, I'm going to get the 4th root of 16. And is there a perfect 4th root of 16? It is 2. So you don't always have to multiply by the same thing, but I need to multiply by something that's going to help me reduce it. So on top, you're going to have the 4th root of 14, which is not going to simplify. And so then you are done. So combining like radicals, you can only combine radicals that have the same index and the same radicand, and you combine them just like you'd combine variables. So if you had the cube root of 8 plus 3 cube root of 8, you would now have 4 cube root of 8. Okay, I usually say cube roots of 8, just thinking this is 1 cube root of 8 plus 3 cube root of 8. Give you 4 cube roots of 8. So as long as they have the same index and the same radicand, you can combine them. And it doesn't even have to be written in radical form, even though we could. Here we have 5 of these. I'll just call them, all right, I have 5 of these minus 3 of these same things, which leaves me with 2 of them. And that's exactly how I think about that. This next one, now, they have the same index, but they don't have the same radicand. So at the moment, I can't combine them. But we might look into, does this cube root of 81 simplify? And your perfect cubes, like to the 3rd power here, 2 to the 3rd power is 8, which does not go into 81. 3 to the 3rd power is 27, and I do believe 27 goes into 81 three times. All right, so this actually becomes then 3 cube root of 3, because this is going to be the cube root of 27 times the cube root of 3 minus the cube root of 3. So if I have 3 cube roots of 3 and I subtract 1 cube root of 3, I'm left with 2 cube roots of 3. Alright, we'll do some more examples in class, but this is to get you started. Let me know if you have any questions, and have a good day. Oops! Kind of closed before I realized I had one more slide. Go ahead, copy this down, and we'll go over what it means in class. Now have a good day. See you later.